Okay, this is the video for lesson 6.4, and it's about solving cubic equations by either graphing or by using the sum or difference of squares. And also I'm going to cover solving equations x to the fourth, quartic equations, in a special case where you can solve it using a quadratic form. Okay, so the first type of problem is solving an equation that looks like this by graphing. So we're going to use GeoGebra to graph this, and I've already put some of the functions in here that we're going to use. So if you'll notice, the left side of the equation is this, x cubed plus 3x squared. I put it in as a function. F of x is equal to x cubed plus 3x squared. And then on the right side of the equation we have x plus 3, a line. I put that in as a separate function. Let me make it visible. And here's the line. Okay, so a way that you can solve a problem like this is by finding the intersection points. So these two things are equal to each other in these three places. And the x values of those three places are the x's that make this equation true. The intersection points. So on GeoGebra, if you use the intersection point, intersect two objects, I'm going to go intersect these two objects here and there, and you'll notice over here on the left I have A, B, and C. The x values of these points are x equals -3, -1, and 1. X equals -3, -1, and 1. These are the x values that make this equation true. You can plug it in to check. I'm just going to check one of them, but if you'd like to, you can check all three. -3 plus 3. Okay, so -3 cubed is -27. -3 squared is 9. 9 times 3 is 27. And -3 plus 3 is 0. So we do get 0 equals 0. It works for -3. It actually works for all of them, just the x values. Okay, so if you see an equation in this form, usually what you're doing is you're trying to find the zeros. You're finding the place that this side of the equation is equal to 0. So we're going to do that right now. Here's the graph of that function. Let me move this over a little bit so you can see. X cubed minus x squared minus 6x minus 4. And what we really want to know is, where does it cross 0? You can see here it crosses twice, and there it crosses once. So what I'm going to do is I'm also going to plot this function, just the line y equals 0 or some function equals 0, and I'm going to find the place that these intersect. So let's do that now. Intersect two objects. I want to intersect them here, here, and here. And you can see the x values are -1.24, -1, and 3.24. -1, -1.24, and -3.24. Okay, let's move on to the next type of question. So we've studied in the past the difference of squares. A squared minus b squared equals a plus b times a minus b. So here's an example of that, of x squared minus 16 is equal to x minus 4, or I'll do it in the same form, x plus 4 times x minus 4. Okay, that's the difference of squares. We're going to take that idea a little bit farther today, and we're going to talk about the sum and difference of cubes. So if you have something that's written in this form, some perfect cube plus another perfect cube, it can be factored in this form here. And this is as factored as it gets. You can't factor this anymore. So let's do a couple examples. Oh, before we do that, notice these two formulas are almost identical. The only difference between these forms is when you have the sum of cubes, you have a plus sign in this first term here, or this first factor, and then you have a minus sign after that and then a plus sign. And the other one, the difference of cubes, you have a minus sign, a difference, in the first factor, and then two plus signs. So both of these have one minus sign in them. If it's the difference of cubes, the minus sign comes first. If it's the sum of cubes, the minus sign comes second. So that might help you in memorizing these formulas. Okay, so if you have something like this, x cubed minus 8, it's of this form, the difference of cubes, where a cubed is equal to x cubed and b cubed is equal to 8. So that means a is equal to x and b is equal to 2 because 8 is the same thing as 2 cubed. So now that we know that a is equal to x and b is equal to 2, we can plug it into this formula, and it's equal to a minus b times a squared plus ab plus b squared. So b is 2, so 2, you could write it x times 2, but the number is usually the coefficient. So we'll write it that way. That's the conventional notation. And then this is factored. That's as factored as x cubed minus 8 can be. If you're going to solve a polynomial equation, you do the exact same thing. This is a plus. 27x cubed is a perfect cube, and 1 is a perfect cube, because 27x cubed is equal to 3x cubed. If I do 3x times 3x times 3x, I have 3 times 3 times 3, which is 27, and x times x times x, which is x cubed. So this is true. So that would be our a value, would be 3x. And then 1 is equal to 1 cubed. So a is equal to 3x, and b is equal to 1. Alright, now we have a sum of cubes, and the formula for that was a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. Alright, so now we're going to substitute in a and b for the values in this formula, and what we get is 3x plus 1 times 3x squared, which is 9x squared, 3x squared equals 9x squared, minus a, which is 3x, times b, which is 1, plus b squared, which is 1 squared. So this is equal to 27x cubed plus 1, and all of that is equal to 0. So if we want to solve this polynomial equation, we now have two factors that are equal to 0, and we know from quadratic equations with factoring that that means that any place where the factors are equal to 0, the entire equation is equal to 0. So 3x plus 1 equals 0, or 9x squared minus 3x plus 1 equals 0. If you have a solution to either of these two equations, it is also a solution to this equation, which is a solution to this equation. Okay, so solving this one, because it's easier, you subtract 1 from both sides, and you get 3x equals negative 1, so x is equal to negative 1/3. So there's one of our factors. This one's a little more difficult. We'll use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. That's a 9, not an a, ac. It happens to be a in this case also. This is b squared, negative 3 squared is 9, and then 2 times a, which is 9. Again, that's a 9. Okay, so simplifying it, you get 3 plus or minus the square root of 9 minus 36 over 18, which is equal to 3 plus or minus the square root of negative 27 over 18. Let's get some more space on here. Okay, so then to simplify this, we could write this as 3 plus or minus 3 times the square root of negative 3, because square root of negative 27 is equal to square root of 9 times the square root of negative 3, and the square root of 9 is 3 over 18. Now we have a 3 that cancels out of both terms, and we get 1 plus or minus the square root of, or I times the square root of 3. This is the same thing as the square root of negative 3 over 6. So 3 and 3 cancel out here. 18 divided by 3 is 6. These are the other two factors. So these are the three solutions to this equation. The most common error that I see on a problem like this is students will be like, oh, I can just solve this directly for x. So they subtract 1, 27x cubed is equal to negative 1, divide by 27, x cubed equals negative 1 over 27, and then take the cube root. It's equal to the cube root of negative 1 over 27. And all this is true. And you get negative 1/3, because that's the cube root of negative 1 over the cube root of 27, which is -1, and 3. And while that's true, this is only one of the 3 factors. There are 3 factors that kind of get hidden when you try and solve it in this way. So make sure if you see something like that, you do the sum of cubes or the difference of cubes. Okay, moving on. The next type of question that we're going to do is using quadratic form to factor an equation that looks like this. So the trick here is to do substitution. So I'm going to substitute x squared for a, and let me show you why. The exponent of this first term is x to the 4th, and the second term is x squared. The difference between these is 2. It's the same thing as when you have a squared, or sorry, it's the same thing as when you have x squared plus x plus 1. If you had something like this, this is a quadratic. The difference between those is 2. And it's actually, what matters is that it's a factor of 2. This is 1. 1 times 2 is 2. 2 times 2 is 4. So it actually works also if the exponent is 6 and 3. If you had x to the 6th minus 2x cubed minus 8, you could use this same trick because the 3 times 2 is 6. So it works for anything that is a factor, anytime the exponents are a factor of 2 different. Alright, so let's go ahead and do the trick. So the trick is to rewrite x to the 4th as x squared squared. That's the same thing as x to the 4th minus 2 times x squared minus 8. And then you do this trick over here. You say x squared is the same thing as a. So let's go ahead and replace x squared with a squared minus 2 times a minus 8. So I replaced x squared with a in both cases where the parentheses are, and now I have a quadratic equation that I can factor. This is the same thing as a minus 4 times a plus 2. That's how this factors. And then I can substitute back in x squared for a. So now I have x squared minus 4 times x squared plus 2. X squared minus 4 is a difference of squares, so it factors to x minus 2, x plus 2. So this is what the whole thing factors to. Okay, solve using a quadratic form. A is equal to x squared again, so that means x to the 4th is the same thing as a squared. 7 times x squared is the same thing as 7 times a. Then I can factor this as a plus 6 times a plus 1, and then I substitute back in, and I get x squared plus 6 times x squared plus 1. And that is factored form. I can then use that to solve equations if I need to. So let's say this equation said x to the 6th plus 11x cubed plus 18 equals 0. I could then say a is equal to x cubed. So now this is the same thing as x cubed squared plus 11 times x cubed plus 18 equals 0. Substitute in a for x cubed, and I get a squared plus 11a plus 18 equals 0. Then I factor this, and that's the same thing as a plus 9 times a plus 2. And then I factor back in, then I substitute back in for a, and I get x cubed plus 9 times x cubed plus 2 equals 0. And this is true when x cubed plus 9 equals 0 or when x cubed plus 2 equals 0. So you actually don't have the tools you need to solve either of these yet. But that's all for this lesson.